Hello again. So let's work through one more example with the quotient rule. So the relationship between demand and revenue, I've actually stated as a product. I mean, it is a product. The revenue is X times the demand. That is a product. But I said this would be an application of the quotient rule, and that's because the specific demand function that I'm going to give will be a quotient. Let's say the demand is 85,000 divided by the square root of x plus 10. Then the revenue is x times the demand, 85,000 times x divided by the square root of x plus 10. And we see that our product has metamorphized into a quotient. And let's take the derivative. All right, quotient rule. It's unpleasant, but straightforward. We take the derivative of the top, and the derivative of 85,000x is 85,000. And we multiply by the bottom. Then we subtract, and now we leave the top alone, 85,000x, but we take the derivative of the bottom. 1 over 2, the square root of x. That's the derivative of the square root of x. The derivative of 10 is 0. So 1 over 2, the square root of x, plus 0. But of course, adding 0 doesn't change anything. Divided by the denominator square. The square root of x plus 10 squared. And this, again, this is really crying out for simplification. 85,000 times the square root of x plus 850,000 minus 85,000 times x divided by 2 times the square root of x. That entire quantity divided by the square root of x plus 10 squared. Well, in the top, this is abhorrent, having a fraction with a fraction up here. Let's multiply top and bottom by 2 times the square root of x. Maybe I won't. So 85,000. Sorry, I just dived right into this problem without giving it a whole lot of thought. There's no need to multiply, there's to clear this out, because x divided by the square root of x is the square root of x. So 85,000 times the square root of x plus 850,000 minus 85,000 divided by 2. And I probably should be able to do that in my head, but from a young age, I have been very bad at mental arithmetic. My calculator says 42,500. Then x over the square root of x is the square root of x. We're not touching the denominator of the big fraction. The denominator of the fraction is still the square root of x plus 10 squared. And now we have like terms. We have this square root term, the 85,000 times the square root, and we have the minus 42,500 times the square root. So the whole thing ends up being 42,500 times the square root of x plus 850,000 all divided by the square root of x plus 10 squared. And simplification took longer than the calculus. Maybe that was kind of annoying to you, but you've got to be able to do stuff like this. Because once we start using the derivative, we're going to do things like take the derivative and set it equal to 0. And if you imagine taking the original unsimplified derivative and setting it equal to 0, I mean, I can just feel the headache coming on. If we're going to want to be able to set this equal to 0, that simplification is not just aesthetic, it's a necessary step before we try to work with the derivative.